Good morning. I am Bhoomi Patil, staff of Saraswati College of Engineering, Kharghar, Navi Mumbai. Today I am going to deliver lecture on Huffman code. It is topic of data compression and encryption subject. Basically, there are two types of compression technique. First is lossy compression technique and second is lossless compression technique. In lossy compression technique, reconstructed signal and original signal both are not identical. There is some loss of information in lossy compression technique. In lossless compression technique, reconstructed signal and original signal both are identical. That means there is no loss of information in lossless compression technique. Huffman code, it is type of lossless image compression technique. Here Huffman code, it was invented by David Huffman. Huffman code, it is used for compression of text as well as compression of images in banking sectors and in medical applications. For calculation of Huffman code, first calculate probabilities of all symbols. If suppose we are compressing text, in that case calculate probabilities of each and every symbol and then arrange that probabilities in descending order and then apply Huffman code. For example, if suppose we are compressing text Saraswati. Here if we are compressing this text, then calculate probability of S, A, R, W, T and I. Then arrange that probabilities in descending order. If suppose at the end of text, if there is any question mark or full stop, in that case consider this symbol also. Here I have taken full stop at the end of text. Here in first step, calculate probabilities of all symbols. First is P of S, probability of S, it is 0.3, it is 0.2, then probability of A, it is 0.3, then probability of next symbol, that means R, it is 0.1, then probability of W, it is 0.1, then probability of T, it is again 0.1, and last symbol, that means probability of full stop, it is again 0.1. Here probability of S, then A, then R, then again W, then T, I, and then probability of full stop, it is 0.1. After that, arrange these probabilities in descending order. For that, first is P of A, it is 0.3. Then next is P of S, it is 0.2. Then next is P of R, it is 0.1, then P of W, it is 0.1, then P of T, it is again 0.1, and then P of I, 0.1, and at last P of full stop symbol, it is again 0.1. This is second step. Here, after arranging these probabilities in descending order, then add last two probabilities. Here, add this 0.1 with this 0.1. Then result is 0.2. Then add this result with upper probability. That means this 0.2 add with 0.1. It is 0.3. Then add this 0.3 with upper probability, that is 0.1. Here 0.3 plus 0.1, it is 0.4. Then again add this result with upper probability, that means 0.1, it is 0.5, 0.5. Then add this result with 0.2, this 0.2 plus 0.5, it is 0.7. Then finally add this 0.3 with 0.7, that means final result is 1. After applying this Huffman code here, then assign zeros and ones at Huffman branches. Assign here 0, then here 1, 0, 1, 0, 1, 0, 1, 0, 1, and at last 0 and 1. Then calculate Huffman code for individual symbols P of A, P of S, R and till P of full stop. Here for P of S, initially here it is P of A. Calculate code word for P of A. First write down all probabilities. Then write down code word. Here first symbol is P of S. For P of S, calculate code word is 0, 1. Always write down code word in reverse direction. Here for P of S, code word is 0, 1. That means write down 1, 0. Write down in reverse direction 0, 1. For P of S, code word is 0, 1. After that, next probability is P of A. For P of A, calculate code word, it is P of A. Follow this direction, initially it is 0. For P of A, code word is 0. Then similarly calculate for P of R, and P of R, code word is 0, then 1, 1. That means write down here 0, 1, 1. Then for next symbol, that is P of W, calculate code word, it is here 0, then 1, 1, 1. That means 3 times 1. For P of W, it is 0, 1, 1, 1. Then next calculate probability or code word for P of T. It is for P of T, first is 0, after that 1, then 1, 1, 1. That means 4 times 1. Here write down 0, 1, 1, 1, 1. After that, next symbol is I. For I, code word is 0, 1, 1, 1, 1, 1. That means write down here 5 times 1. Similarly, calculate probability for last symbol, that is full stop. Here for this full stop, code is 1, 1, 1, 1, 1, 1. That means write down here 6 times 1, 1, 1, 1, then 1, 1, 1. In this way, we calculate code for text Saraswati, and at last there is full stop. Text is Saraswati, and at last I have taken here full stop. here for this text we have to send this code word during transmission of information Saraswati. If suppose this Saraswati word is repeated 1000 times in book or any PDF file, in that case instead of sending each and individual symbol as a r 1000 times, instead of that simply send there this code word only this code word for single time. That means it requires minimum time for transmission, as we are sending one code word single time instead of sending 1000 symbol 1000 times. It reduces our memory space, it requires minimum memory space to store that information. Also it requires less processing time when we compress our data and decompress our data. In this way we compress our text information by using Huffman code. We can compress images also by using Huffman code techniques. In Huffman code techniques, if we want to compress images, in that case consider their probabilities of pixels, intensity of pixel values, calculate intensity of pixel values, then calculate probabilities of that values, then arrange that probabilities in descending order, and similarly apply Huffman code to that calculated pixel values and compress image by using this Huffman code. Just convert that calculated value into this code word form and transmit that information from transmitter to receiver. Similarly, we can use Huffman code for the compression of audio informations also. For compression of audio information, use their samples. Convert samples into digital form and calculate probability of that repeated samples, then arrange that probabilities in descending order and apply Huffman code and compress data. That means by using Huffman code we can compress text information, we can compress audio information, and we can compress image information also. Mostly Huffman code it is used for compression of text images and compression of text and compression of images, because for compression of images in medical application there requires some precautions because this is related to patient, and in banking sectors where required text information requires security to that data, in that case use their Huffman code for the compression of text information.